Today I'm going to tell you about the Betelgeuse star, which may collapse in the near future, and about the threat it may pose to us. Betelgeuse is the 10th brightest object in the night sky. It is located 430 light-years away, in the constellation Orion, and in the near future, it may become a supernova. The star is about 8 million years old, while the Sun is 4.5 billion years old. But Betelgeuse is consuming its nuclear fuel too quickly. Therefore, astronomers already consider it a doomed star. At the end of 2019, astronomers reported that Betelgeuse's luminosity had dropped to 36% of the standard. That's why some scientists started talking about a supernova explosion as being able to become one of the brightest objects in our sky. Now let us tell you what the Betelgeuse star is. It belongs to the class of red supergiants. It is now at the end of its life cycle. Its luminosity and radius are constantly changing, and its outer shell is extremely unstable. The mass of Betelgeuse is about 17 solar masses. If we put it in place of the Sun, it would absorb all the planets up to and including Mars, and a significant part of the asteroid belt. Betelgeuse is a very bright star. Its luminosity is 90,000 times higher than the Sun's, and at its maximum, it can be 150,000 times brighter. The star was formed about 8.5 million years ago, and its initial mass did not exceed 20 solar masses. In addition, Betelgeuse is the first star after the Sun to have an image of the disk and spots on it. Red giants burn fuel very quickly because they have such a short lifespan. Some hypothetical models of such stars, with nuclei of heavier elements than hydrogen, can exist for no more than 1,000 years. The burning of hydrogen in the middle of Betelgeuse led to the fact that the center stopped producing energy, and the temperature and density increased. The increase in temperature and density in the stellar core led to the ejection and expansion of the outer layers of Betelgeuse, in which a new source of thermonuclear reaction was activated: helium burnout, which is typical for red giants. Red giants, due to their size, can emit a tremendous amount of energy and heat, although they are relatively cold objects. For example, the surface temperature of Betelgeuse is 3,300 degrees, which is almost twice as cold as the surface of the Sun. According to the theory of stellar evolution, Betelgeuse should explode in a supernova in the next 10,000 years, releasing a tremendous amount of energy and subsequently forming a neutron star, or black hole from its core, if its actual mass is 30% greater than predicted by astronomers. At this point, Betelgeuse's brightness will reach the level of the full moon in the night sky, and it will gradually dim over several months. An event of this magnitude will help us gather more information about the evolution of stars and the universe. Stars several times more massive than the Sun, such as Betelgeuse, usually have a blue, white, or red color. But before transforming from young to colder and older red giants, they go through a short yellow-orange phase. In the case of Betelgeuse, this could have happened decades ago, as Ptolemy noted in his notes. In this case, we can testify that the star will explode in about 1.5 million years. Another hypothesis is that Betelgeuse was once a double star. Sophisticated computer modeling suggested that as it aged, one of the stars expanded and absorbed the other by mixing. It increased its rotation speed compared to other similar stars. Calculations show that a star like Betelgeuse can pose a danger within a radius of 100 light-years. Currently, it is impossible to predict whether Betelgeuse will erupt in a supernova. It will be possible to predict this event a few days before the outbreak itself. At the same time, it is assumed that the gamma-ray flare stream may pose a potential threat to our planet. Let's understand what this gamma-ray supernova flare is. At the end of a supernova's life cycle, at the moment of explosion, the star releases as much energy as the Sun emits in 10 billion years. This is a very powerful release of gamma-ray particles. At high speed, it can last from several milliseconds to several tens of seconds. At first, the radiation is characterized by high power and can destroy all life in its path, but with increasing distance, the flux density decreases and gradually dissipates in outer space. It is estimated that the star's matter will take 6 million years to reach the solar system. By that time, it will be sufficiently dispersed and the speed of the shock wave will decrease to 13 kilometers per second, and it will be successfully extinguished by the solar wind. Therefore, Betelgeuse does not pose a threat to us, and its explosion will be a very interesting and informative event in the history of mankind. I hope you enjoyed this video. If you want more interesting information about space and astronomy, be sure to subscribe to our channel. Don't forget to like this video so we know you appreciate our content, and leave us a comment with your thoughts and questions. Thank you for watching, join us, and see you soon in the depths of space.